Hi, this is Andrea, and I'm going to talk to you about the work that myself, Andrea McPherson, and Mathieu Barthet did on real-time recognition of percussive techniques on the acoustic guitar. We bring real-time hit classification of percussive guitar techniques as an example application of real-time music information retrieval, or RT-MIR. The main constraint of real-time musical performance is this: between an action and its response, there should be a latency of around 10 milliseconds with minimal jitter. Furthermore, if we want the model to be deployable in practice, it has to be relatively small so that it can be run on the processors of embedded computers. Our goal was to design a model around these constraints. It would have to acquire only 10 milliseconds of data after the detection of a guitar body hits attack. To create a relevant training dataset, in past works we studied the techniques of percussive fingerstyle guitar players, then we built a prototype augmented guitar with a network of 5 piezo sensors and 1 magnetic pickup to optimally capture their technique. Our input data is a 10 millisecond snapshot of 6 audio channels. The labeling of the dataset was done according to a taxonomy inspired by KL-Divergence's work on bass playing. The labels got simplified into a 2-class scenario, a heel hit versus a hit with any other part of the hand, a 4-class one comprising all the hand parts in the taxonomy, and the hierarchical label including hand part and location on the guitar's body. We acquired over 3,000 examples into a dataset of labeled guitar body hits played by the main author. For the network architecture, we were inspired by Ma et al.'s 2021 study on automatic drum transcription applied to tabla sounds. We took their convolutional architecture and adapted the input dimensions to fit our 10 millisecond window. We also designed another network with 3 main differences. It uses downsampled FFT magnitude as input representation. It has 3 1D convolutional layers rather than 2 two-dimensional ones. And its last dense layer is a very small two-dimensional bottleneck to aid operations such as parameter mapping in a DAW or in an audio plugin. We wanted to make that small bottleneck also encode meaningful information beyond the decision boundary of the technique class. Our CNN was extended with a reparameterization layer and a decoder, making it a VAE. The loss function was extended accordingly. This was evaluated qualitatively with the KL-Divergence between distributions of categories that the model was not trained to discriminate, for example, all hit intensities within all finger hits. The classification results are very promising for the 2-class case, although less so for the multi-class and hierarchical classification tasks. Some models showed a bias against heel hits, potentially due to an imbalanced training dataset, as not all positions of the guitar's body are reachable with a heel. In the pictures on the right, you can see the latent space distribution of hits done with the fingers, separated according to dynamics for Perc-CNN and Perc-VAE. We can notice that in Perc-VAE there's a growing KL-Divergence from one dynamics level to others, meaning that the examples are weakly ordered for growing dynamics in a given direction. The Perc-VAE model was effectively run in real time on our augmented guitar prototype, the HIT-R. Many users beside the main author were able to play with the model effectively, either using the sounds produced by MIDI sample packs or controlling the parameters of the synthesis engine Metasynth by CNRS Prism Laboratories. However accurate the model is, the interaction may benefit from the ability of musicians to adapt their technique until they can reliably produce the sounds they're after. This is the object of our current investigations, which are underway. I thank you for your attention, and I invite you to hear the HIT-R played live for the music program at ISMIR. I also thank the sponsor of this project, the Artificial Intelligence and Music CDT at Queen Mary University of London, funded by UK Research and Innovation.